All right, so real quick, again, I want to run through this one more time, just to make sure we're all on the same page. So this is going to be important. Now, if you want to write this at the top of this, what type of reactions do you use this with and only with? Single replacement. Write that at the top. Only for SR. And SR stands for single replacement. If you want to write out the whole word, be my guest. Okay. Again, one more time, just kind of throwing it at you. And again, because I should have been recording this the whole time, but I have not been. And I told you guys to draw a line, make it black. Draw a line between those two things. And what did I tell you about that line? Don't cross it. When you start on one side, stay on that side. Completely, totally separate topic of information. However, I do want you to understand. Actually, two things. Number one, what did we say about the order of this list of the halogens? Very good. It's in the same order as the PT. Again, that stands for periodic table. And the second thing that I wanted you to understand, why are all those little bitty 2's there? Very good. So, if you ever see fluorine, chlorine, bromine, and iodine, will you ever put just F, just Cl, just Br, and just I? No, you have to put the little bitty 2. There are 3 other diatomics. Who are the other 3? Oxygen, hydrogen, and nitrogen. Remember, they all end in gen. Hydrogen, nitrogen, oxygen, and the halogens. Okay? Also, we talked about this. This first group, this top group, is it the most reactive or least reactive? It is the most reactive. So again, if you want to call this the hotness list, who is the hottest on the list? Lithium. Hold on just one second. All right, so let's look at our first problem. And again, we'll kind of bounce back and forth to that right there. The first problem, guys, sit. Okay. It says lead plus zinc acetate. All right, so first of all, lead. What's the chemical symbol? Pb, very good. So I've got Pb plus, and then it says zinc acetate. Now, if you want to write on this half sheet, be my guest. If you want to write on your own sheet of paper because you don't like of how small it is, that is perfectly fine. You do whatever works best for you. So I'm actually going to do this in 2 different ways. If you're writing on the half sheet, write what I'm fixing to write above the words. Above the words. So zinc acetate, we got to figure out what the formula is. Now, what is the charge of zinc always? Zn2 plus. Acetate is going to be the one that gets you. Hopefully you remember that one by now. What is acetate? And what's the charge? Negative. Okay, so that is our charges. Those are our ions. And what do you do with the ions to make the ionic bond? Crisscross. You say crisscross? Is that what I heard? It is way too early to be that country. All right. So, here's the deal. We've got to determine if lead, the single person, shows up at the party and is ready to kick somebody out and steal their date. But let me ask you something, okay? Who's that rapper, Mr. Steal Your Girl? Oh, wow. I should have never asked that question because I don't know who that is. So here's the deal. We've got to figure out if lead can kick out somebody. My first question is, what side of this activity series are you going to start on? We're going to start on the left side. Why aren't we starting on the left? No. Lead is a metal, so we're going to start on the left. So let's find let's find lead, and then we've also got to find zinc because it's a metal. So let me ask you something. First of all, let me actually bounce to this so I can actually write on it. Lead is right here. Where is zinc? Above it. So put your finger on both of them. Which one is the highest? Zinc. So can lead kick zinc out? Darren, will you let her in, please? No. Darren, will you let her in, please? So look at your instructions at the very top of the sheet. It says, number 1, write the formulas of the reactants on the left side of the yield sign. Step 2, look at the activity series, determine if replacement can happen. Yes, ma'am. Emily. And then number 3, if the replacement can occur, complete the reaction and balance it. If the reaction cannot happen, what do you do? Write NR, which stands for No reaction. That's exactly what you're going to do tomorrow. So again, this would be NR. So if I took some zinc acetate solution, okay, it's in a beaker, it's floating around, and I dropped a piece of lead in it, would it react? No, you would see nothing with your eyeballs. Absolutely nothing would happen. Okay? We go with that. Yes, sir. Nothing would happen. Okay? This is the atomic level. Nothing happens. Now, think about this for just a second. What is lead used for? No, that's graphite. That is, and that's always gotten under my skin as a chemistry person. People call them lead pencils, and that is the complete and total falsification of the truth. It is pure carbon in graphite pencils. Because they used to be hundreds of years ago lead, which now can poison you and kill you. But that's besides the point. So, this cannot happen. You can use it for cooking surfaces. You can use it for all kind of things, and it does not need to react. Yeah. Yeah, because it's not going to react. Lead poisoning? Sure. All right, number 2. Maybe not cooking surfaces. Iron plus aluminum oxide. So what's the chemical symbol for iron? Fe plus. Now, I think I put this formula on every single test, every single year, and I would say about 50% get it right and 50% get it wrong because they have no idea how to treat aluminum oxide. Remember, these are ionic bonds, and ionic bonds are made of ions. And what is the charge of aluminum, and how do you know? 3 plus because it's in group 13. What is the charge of oxygen? 2 negative. What do you do with those ions? Crisscross them and it forms an ionic bond. So this is the reaction. Alright, so we have to now consult our activity series to see if poor little old iron can kick out who? Aluminum. Why are we trying to determine if it's going to kick out aluminum or not? It's a single replacement reaction. So I'm actually going to back this off so we can actually see it. All right, so let's find iron and find aluminum. Put your finger on both. Put one finger on both of them. That was a joke. Okay, so we've got aluminum here and we've got iron here. Who's on top? Aluminum. So guess what? It does not work. So what would you come over here to the right of that arrow and write? NR. I promise you we're going to get to some that work, I assure you. Okay. Matter of fact, this next one's going to work. Now, just looking at it, how can you tell just by reading it that you know it's going to work? Silver. Okay, very good. So it says silver nitrate. So we're going to start with what's listed first. So silver's always what charge? 1 positive. Silver's always a 1. Nitrate is NO3 what? Negative. Come on now. What do the charges do? Cancel. So we've got AgNO3 plus nickel. Now, what is nickel's chemical symbol? Ni. Now, I'm going to go ahead and prove it to you, but you guys tell me, is this one going to work? Yes, you know that because we've already talked about the fact that the last 3 on the list are silver, platinum, and gold. Okay? So, if you find silver, just to prove it to yourself, is nickel higher on the list? Yes, nickel is right there. All right. So here's what we got to do. Who is going to get kicked out all by its lonesome? Very good. So let's go ahead and write that down. So we've got silver plus. Now, this is the new phrase you're going to hear me say a lot. Charges. New compound equals check your charges. And some of you have already caught the issue. Do you know the charge of nickel? Is it 2? Is it always 2? No. Here's the good news. Actually, Sam, that's a great hypothesis. I'm going to say no, but it's plausible. So here's the deal. On the test, if it's a transition metal, I will tell you, my goodness, is they interrupted today? I will tell you which charge to associate with the transition metal. Yes, ma'am. Next year. Gotcha. Thank you. Before you guys leave, I need you to, on this is next year's grade. So if you put this year, you may want to come up here and change it at the very end. Okay? So we're going to pretend that, again, we're going to say that this is nickel 3. On the test, I will tell you which nickel it is, whether it's nickel 2 or nickel 3 or iron 2 or iron 3 or lead 2 or lead 4 or whatever. I will tell you what the charge is, so you don't have to worry about that. But who is nickel now going to be hooked up with? Nitrate. Is that a new compound that you have not had yet? What must you do? Check the charges. All right, so I'm going to write it up here. I just told you that nickel is a 3+, correct? Okay. Does nitrate change? Nope, nitrate's still the same. So it's NO3-. What do you do with the ions in an ionic bond? Crisscross. I cannot write that in pink. NiNO3. Now, I'm going to ask this question and see how many yeses I get. Are you finished? Why not? It's not balanced. See if you, by yourself, can balance this. This is an easy one. This is really easy. I told you it was easy. Okay. All right, how many silvers do I have on the left? 1. How many silvers on the right? 1. How many nickels on the left? How many nickels on the right? Now, do you see a polyatomic? Is it on both sides? So you're good. How many nitrates on the left? How many nitrates on the right? 3. That is an issue. So I'm going to come in and I'm going to put a 3 here. But who else did that just affect? It also affected the silver. So that is it. Is that what everybody got? Good. Okay, if you didn't get that, we need to work on that. Yes, sir. That's a great question. No, it does not matter. As long as they're on the right side of the arrow. So what I'm basically saying is, and this is a really good question, can you swap those two? Yes. Can you swap these two? But can you put one of the yellows on the green? No, that's the part you can't do. So that's a really good question. As long as the reactants stay reactants, and as long as the products stay products, it does not matter what order you put them in. It's a really good question. All right, looking at the next one. It says sodium, bromide, and iodine. All right, this is going to be a little bit trickier. All right, so sodium, bromide. Again, I'm going to start with the charges. First of all, no, let's not start with the charges. What group is sodium in? 1. What's its charge? 1+. What group is bromine in? 17. What's the charge on group 17? -1. So what's +1 and -1? They cancel, so I've got NaBr. Plus, and it says iodine. Now let me ask you something. If you wrote it like that, are you right or are you wrong? You is wrong. Why is you wrong? Look on your list. Look on your activity series. My first question is, are you on the left side of that line or the right side of that line? The right side. What do you notice about all those little letters when they're by themselves? They've got a 2. Again, please do not forget about your diatomics. Yes. You can, but we're not at that point yet. Okay. Now, so let's look on the list. Who is I going to try to kick out? BR. Can it happen? Why not? Okay, so I'm going to prove this to you guys. If you look on your list, again, we're on the right side of that line that we drew. There's our 2. BR is above I. So this will not work. So what do you write on the other side of that arrow? NR. You agree this is fairly simple? It's not? Okay. All right, let's move on to the next one. Aluminum bromide and chlorine. Again, aluminum bromide. Guys, this is just like naming compounds and writing formulas. Aluminum bromide. So, Al is what charge? 3 plus. Bromide, we just did it, is what? 1 negative. How do you know it's 1 negative? It's in group 17. Okay, so what's your chemical formula? AlBr3. Does that make sense? And then it says plus chlorine. So is it just plus Cl? Okay. Again, on the activity series, what side of that black line are you on? The left side or the right side? The right side. And what do you notice about all those elements? They've got 2's. Now, let's go back and look at the activity series again. Is Cl above Br? Yes. So can this one work? Yes, this one can work. So who's going to be out all by their poor little lonesome now? Br. Poor little bromine. Now again, I asked this question. Can you leave it as is? What do we know about the halogens? They're diatomics. Okay. Who's chlorine now with? Aluminum. So I'm going to go back one slide, or 2 slides, one. New compound. Is Al been with Cl before? So what do? Check the charges. So we're going to write a brand new formula. What group is aluminum in again? Did it change? Nope. It's 3 plus. Chlorine's in group 17, so it's 1 minus. So what's your chemical formula there? AlCl3. Is it completed? Balance it. See if you can balance it. What little rule do y'all see? 2, 3, 6 rule. Very good. So I've got 3 bromines. I'm going to put a 2. That gives me 6. I've got 2 chlorines here, and I've got 3 over there, so I'm going to put a 3 here. Well, that means I need a 3 here and a 2 there. That makes sense? So now again, does the Br2 or the AlCl3, which one has to come first? Neither. Doesn't matter what order you put them in. Any questions? Ask now. Okay. All right. Go ahead. Uh-huh. You will 99% of the time have to balance. It's very rare for it to balance itself out. Okay. All right. What number are we on now? Sodium iodide. Now, I just plopped that thing down like I knew what was going on. How would I know that it's going to look like that? What group is sodium? So it's 1 plus. What group is iodine? 1 negative. So they're going to cancel. And it's going to be with bromine. So it's going to be Br what? 2. What side of that line, or first of all, who's trying to kick somebody out? Bromine, he's by himself. So what side of that line on the activity series are you on? The right side. And you can even look at the periodic table for this one. Is bromine above iodine? Yes. Okay, so who's going to be kicked out by itself? Iodine. Now, what do we know about iodine? It's a diatomic plus. All right. Who's now going to be hooked up? Sodium and bromine. Is that a new compound? What must you do? Check the charges. What group is sodium in? 1. What group is iodine in? 17. So what do we know about their charges? They cancel. So NaBr. Sorry, NaBr. Well, you guys know what I meant. See if you can balance that one. This one should be super easy to balance. Dang, man. I don't like these last ones. I'm going to go ahead and tell you that I'm not going to give you any with water in them. Or acids. What's wrong? What's wrong? Okay. No. 2 and 2. Is that what you got? All right, I do want to do number 7, and I'm going to make everything else up because I don't like any of the rest of them because they're a little weird. And there is a reason why, and I'm not going to get into the reason why. All right. So let's do number 7. So calcium plus what is hydrochloric acid? This is probably one of the only acids you probably know. HCl. All right. So this is why this one's a little bit weird. Who's by itself? Calcium. So we are going to be on what side of the activity series? The left side. Now, so he's either going to try to kick out H, or he is either going to try to kick out Cl. On your activity series list, and actually let me go to it. Who is calcium going to try to kick out? Very good. If you notice right here, H is on the left side, but here's something that's weird. Why is it H2? It's a diatomic. Very good. So can calcium kick out hydrogen? Yes. Now, again, it's got to be H2, correct? Yes, sir. Hydrogen is one of those things. It can act as a metal and it can act as a non-metal. It's carbon and hydrogen are the two weirdest things up there. They can do a bunch of strange, random things. Yes, that's why it's in group 1. Okay. Now, calcium is now with chlorine, and this is the important thing that I want you guys to see. Is calcium and chlorine a new compound you've never seen? Yes. What do you do with new compounds? Check the charges. What group is calcium in? It's in group 2, so it's a 2+. What group is chlorine in? Which is what? 1-. So we've got CaCl2. Now balance it. What'd you get? That should be it, right? Okay. All right. I'm actually going to make up some because I don't like 8 through 11, and I did not realize those are on there until, honestly, right now. Let me do something real fast. Pause this video.